Okay, hi guys. How are you today? Where are everyone? Maybe midterm? I don't know. Anyway, nice weather, so it's a great time period. So yeah, you are expecting the spring break next week, right? So hope you have a great your time or with family. Okay, so today this is the third time the intercepting communication. Okay, so thank you for some the comments or your thought in the Discord about this class. So I will consider your opinion, your idea. So um, I also learning how to teach the students. Okay, so following the last class, today we will cover maybe challenge 8, 9, 10, and 11. Okay, so intercepting, what we need first to intercept the traffic or the connections. So we have to scan the network environment first, right? How can you do that? We can use some basic commands like ipconfig or uh, route commands or ALP commands, and also we can use the dedicated tool, the nmap, right? So using nmap, we can scan a lot of network hosts within a very short time. But in challenge, I know there's a big class that is not small network, so big class. 2 to 16 hosts exist. So that means it takes a long time. I saw sometimes someone post, uh, it takes maybe 40 minutes or 1 hour. It depends on how many resource running on server. Anyway, after that, what will you do? Yep. No. Ooh, what happened? Um, and then we have to decide which server, which host is a target to intercept the traffic, right? So if we decide the target, we need to try to get some information to intercept the communications, like um, sorry, it's a synchronized camera. Mm, so we need to uh, get some information like IP address of target, right? And the port number for the TCP protocol. And uh, using those basic informations, that we can try to listen passively the traffic, right? The, we can set the filter based on the IP address or some specific uh, protocol like a TCP, UDP, ICMP, ALP. So yeah, we call that the monitor. or the sniff. So sniff is more aggressive tones, right? Sniff, that's not legitimate. That's not uh, a good way the, to get information. Anyway, so in the Scapy, there is a good function to monitor the traffic. There is a sniff. So these are the usages, how to use the sniff functions. So in our challenges, we can have some good level to check this sniff. I think that gonna be the level 6. So let me move that. Okay, let's move to level 6. Okay, in the level 6, we can see um, challenge long, right? When we learn TCP dump, we see, oh, a lot of traffics there in the network. So you can see uh, 03 to 02 and port 31, 337, or from oh, 02 to 03. Yeah, there is some traffic. How can we snip this traffic uh, other than TCP dump? So we can use the Wireshark, the high-level visualized tools, right? But let's say we need to use Scapy, the Python module. Okay, so how can we snip that? Let's say Scapy. Okay, here we can like a P packet snip. We need to specify the interface iface. What was that? E either 0, right? And let's capture only count. Number is 5. Okay. Yeah, it's done capturing by packet. So how can we see P and the method show? Yeah, so we can snip actually the capture the packets using the the snip functions in Scapy. Okay, so this is the way to monitor in Scapy. So why we need to monitor? Why we need to snip? So in this the module, the every challenge, maybe you need to you want you would, the check of my packet is well organized. My packet is transmit well to the to reach out the destinations like that. You wanna check the reachability or some many errors or the response from the server. In that case, you can uh, capture the packet and print out that, and then you can understand. Oh, so my packet is not well organized, or the target server destinations, uh, there it has not connectivity like that. We can check. So now we understand how to use the sniff functions, and also one of the functions I wanna share with you. Um, how can get the IP address, ALP MAC address of this interface? So you can use the um, get. Uh, okay, say it again. Get IF. Yeah, get IF. Yeah, right. So we can uh, interface name here. Yes. So why this function is the benefit when you craft the package. So we don't need the address, the MAC address of our interface sometimes, usually. So just you can specify these functions instead of the real MAC address of source uh, the device. Okay. Okay. Thank you for helping me. And let's move the level, okay, 7 and 8. So manually send Ethernet packet. Okay. So how to send the email Ethernet packet? So I will show you some script in Scapy script, and um, also I will describe some the foundational knowledge for to capture the idea of the each challenges. Okay. Mm, so let's initiate this. Okay. So here I brought some the code, ready-made code. Uh, so actually the level 8. Uh, what is the challenge again? Okay. Mm, run. Yeah. So manually send the Ethernet packet. So the Ethernet functions packet should have either types all F, right? And the packet should be sent to this IP. Okay, so this example, there's no um, either types, right? And also it has different IP address. So to make a packet to and send, so there's two ways. The first one is a CLI interface mode, like a start as copy, learn Scapy, and type the each statement. But that's not a good way to debug and modify, right? So in this, like this, you can use the VS code, coding like this. The first line, the input module, Scapy, right? And you can use the either and ALP. How can we uh, get help the syntax or format of these functions or method in the Scapy? So we can, oh, what's the clear in the Scapy? No. Okay, it's good. So I like to see half and the either. Yeah, they give some gives like the prototype of the functions, right? So packet destination source types, and yeah, they give us detailed information of the functions. See, so the last times I like that ether and show method, right? So the first field is a destination source address and types. So we need to the destination field. In this case, the OF means the broadcast address. So this packet will broadcast on the network, and the ALP, the IP address for the destinations. So 192 and 10. So when you send the packet, already mentioned maybe in the previous class, send the P send packet at the link layer, the layer 2 uh, format. So you have to specify the interface name like this. Okay, okay, let's check. At first, let's do this on command mode. You just copy and paste here. No, what? Copy, paste. So ALP request and the send. Yeah, it's sent. But how can we do that? How can we know this packet is sent successfully? So we can use TCP dump or the Wireshark. What would you like to use? Let's use the Wireshark, the desktop. So let's go to the challenge mode and learn Wireshark ampersand. Ampersand means the learning background. Okay, and we can start the interface is the zero. Okay, now okay, let's send again P. Maybe they do not. I think they recognize this is different network. Okay, so let's do the desktop diagonally. So let's move C and Python. Okay, let's Python send P AL P ALP. Okay. Yes. So here you can see the packet was sent successfully, right? So you can check that details on this panel, the Ethernet, right? The broadcast address and source address, yeah, types, and ALP, the IP address, right? We set the 10. In this way, you can debug, oh, my packet is delivered successfully or not, or my packet has some uh, the wrong value. So like this, you can check that. Okay. So that's send the P ARP, right? Yeah, to the same source. So let's open. I have another uh, sample source here. Let's. What is the top the upper layer of the ARP? Ah, the Ethernet layer, IP layer, right? Ethernet IP TCP layer. That's a TCP stacks, TCP IP protocol stacks, right? So let's check the second sample code I put here, send P IP. No, we did P. Oh, either. I just sent the ARP, right? Yeah, let's. Um, so ARP here. Okay, let's send the ARP frame. So sorry, Ethernet frame. Okay, this is the source code. So destinations, broadcast, source, and yes, you can use the get if address functions instead of this the fixed value. Okay, and type and IP. This is the destination and source, and then the highest protocol is ICMP. So send the P what this frame all protocol combined in a frame, right? Ethernet, IP, and ICMP. There's a combined name of the frame. Name is frame, right? And interface, the ET at the 0. Okay, let's check this. First, Python can right, and here sent. Yeah, the ICMP package sent, right? So you can investigate it, the setting value you put in the code, right? Okay, and then uh, let's send the payload. The payload is application layer. So application layer is the creator of the data to transmit. I mean, say payload. Yeah, you can see that everything is same, but there is another parameter, the payload, right? And there is a low functions. Okay, so I put some strings, hello ASU, right? So when you capture this packet, we can discover these strings. Okay, so there's a TCP port number because this is a TCP segment. Okay, let's send. this one, like a Python, send p payload. Okay, okay, send. Yeah, here. So it shows FTP protocol, but that's not real. That's not true, right? Anyway, I see IP protocol, TCP protocol, and there's a yeah hello ASU. Like this, the packet we craft, they can be captured and shown in this way using the Wireshark. And also you can use the TCP dump. Um, Again, this the how to debug of these challenges um, when you are solving the challenges. Okay, send P. So let's back to the presentations. So TCP, you need to understand how to encapsulate it in the protocol stack uh, to address the challenges, maybe 11, 12, 13. So because uh, this is very a critical part of TCP/IP protocol, how the TCP connections are established and how can they keep the reliability or integrity of the connections. Okay, maybe you already learned this part in other class, network maybe class. Let's have some review. Okay, there's a data to send. So we call that the TCP data. So sender want to send that to the receiver. To do that, like a envelope, we have to attach the some header information for that data. Okay, we call that TCP header. It has port number, right, and some flags informations to control that packet. Okay, so this we call this segment TCP segment put in the lower layer protocol. That is the IP layer, right? So IP layer pack this data and attach its header. So what kinds of information in the IP header? So TCP has port number and IP header has what? IP address, right? 4444, 4 byte address, right? So IP address is very important in IP layer. So that's the kinds of identity in the internet. IP header describe this the packet data segment. So we call that packet. So IP packet, that's why I call the IP packet. And then those data can be input to the next layer. We call that the Ethernet layer, right? And attach the Ethernet header. We call that frame. So in the TCP layer, we use the term segment, TCP segment, and IP layer, we use IP packet. And last one, Ethernet layer, we use the frames, Ethernet frame. So Ethernet frame also pack the upper layers, the payload, and attach the header. What kinds of information in the frame header? Address. What address in the Ethernet layer? MAC address, right? 6 byte. hexa value. Yeah, so each layer um, has its own header information. Based on header information, the payload, the data, will be analyzed and processed. So lastly, those packed information and data will be delivered through the physical layer, like radio wave or 3G, 4G, 5G network, or Wi-Fi or our Ethernet wired network. Okay. In the receiver, you just reverse the order of this uh, procedure. So we call that decapsulations. So TCP should be proceed with this process encapsulations and reversely as sent at a receiver decapsulations. So what is the first steps to use TCP connections? We call that setup. And in the setup, as I mentioned, there's a three-way handshake. HS means a handshake. Okay. So the first packet, what is that? The sync packet. The sync, that is one of the TCP flags information. Um, the sync is synchronized. Let's talk first, and it includes the number, two numbers, the sequence number, and the acknowledged numbers. So these two numbers are generated by the OS, the kernel. Uh, so this random number are generated by some specific standard method. So let's say the sequence number start 6574 and acknowledge the 0. The server, when receive this packet as a response, he send the ACK uh, packet. So the sync flag set one in the response, the ACK flags set one, right? And the number of the sequence also generate by the OS and send the ACK number, the ACK number calculate by add one to the sender's the client sequence number. So 6574 gonna be 6575 plus one. Okay, and then lastly, client acknowledge that response with the the same the number as a sequence and acknowledge number that is uh, the add one to the previous sequence number from server. Okay, so this green color affect each other and yellow color affect each other. Okay, increase by one. So can you make this? Yep. Does it always increase by one, or can there be some other hash function? In the setup phase? When we are converting the sequence number to the acknowledged, when the SYNAC packet is being received by the client, will the number always be incremented by one, or is there some other function which determines? There's no any functions, only plus one. Yeah, and uh, in the data transmission phase, there's some different. You have to add the length of the data in the in the sequence number like that. I will say later. So if you like to craft this two-way handshake, actually the level 11, they request you have to uh, perform this way handshake manually. Okay, so you have to make the sync packet first, and then egg packet, and also lastly egg packet. So you have to concern the number of the sequence and acknowledge number to make work to make it work. Okay, so the flags. Okay, let's see first the sequence number. Yeah, that's the position of first byte of data in a segment within a data stream. So this is the start in the handshake. Three-way handshake, that is the start number of the data. For example, here 13423 and payload 35. That means it has some. So this is not the case for three-way handshake. I think this is the data transmission exchange phase. So if the packet has a payload is data to send 35 byte, you should add this length to the sequence number. So that's gonna be 13458. Okay, like this. The receiver. This is the way to acknowledge I receive your data without any errors, based on the the, uh, the increased data increased numbers. Okay, so if the number or the size is different from expected numbers, there are maybe dropped or lost segments. So like that, data when the data is reassembled, we could check the integrity or some error, the transmission errors. So the sequence number and acknowledge number, those are very critical mechanism to assure this integrity or the error correction mechanism. So acknowledge number also the same. Let's say the acknowledge is 167554. The if the so actually this acknowledge number gonna be the expecting number from the server or sender. Okay. So what I mean? Um, okay. Okay. Let's see these scenarios. So here, data exchange phase. So first phase is a three-way handshake. After that, we have to exchange the data, right? So the sender, the client number is 65575 and ACK7612. The ACK, the set to and the payload 25. In this case, the 25 should be added the sequence number, that is the ACK number. So this ACK number is expecting number from server as a sequence number. Okay, yeah, that's my the sequence number here 6000 Okay, because yeah, uh, it has also a 30 byte payload. It will be added the sequence number, and that's gonna be the ACK number. So this ACK number will be the sequence number uh, from the client number in the next transmissions. Okay, that the meaning of that the acknowledge number. Okay, any question? So the sequence number. So that's these the two numbers. That is uh, the managing schemes of TCP reliability. Okay. for retransmission case and duplicated transmission or receive and flow control. So the sequence number give us that information regarding these three case. What is TCP flags? So there are six, maybe six flags. The first one sync, egg, finish, reset, urgent, push. So sync case, there's the first segment in the three-way handshake, right? And egg, basically egg is the receipt. I receive your data well, right? And fin is a finish. Let's terminate, finish these connections. Okay. And RST reset, request immediately reset the virtual circuit. Um, if I received unexpected packet or data from remote host, in the case, oh, this is not mine. In the case, you can also reset that connections, reset the session that maybe there is kinds of yeah, connections. Okay, and urgent and push. So I don't see usually these flags are used in the real world. The urgent and push. Let's just say remember that full length urgent and push flags. Okay. How to set this sequence act and flags information in the Scapy. Okay. So first, this is the IP address, and yeah, uh, there's the parameter of the flags, and we can use the initials of each flags: S, A, F, U, P. Okay, so we can. So also sometimes we use these combined letters like a sync and ACK. Okay, is that? And then um, yeah, here combine this TCP packet and I packet. Maybe number 12 is a send P this packet to specific interface. Okay, this is the basic usages how to set. So to make the manual three-way handshake in Scapy, you need to understand this format, and you need to follow the order or uh, like some parameter has the quotation mark, but the numbers they do not has quotation number. Sometimes the IP address has quotation mark. So here, two network terms: connection oriented and connectionless protocol. Have you ever heard of this? Connection oriented and connectionless. What's different? So TCP. So I brought some examples like a long love letters should be cut and put in a one postcard and sent one by one, right? And the receiver have to reassemble in based on the sequence number, right? So this process is kind of a logical connection between two parties, not physically connect, but sender and receiver they thought, oh, my data sequentially well delivered, and I can also read the data without any issues. So that makes feel, oh, we are connected logically. Make sense? So those methods we call that connection oriented protocol. So TCP protocol is one of the mainstream of the connection oriented protocol. Using sequence number and acknowledge number, they keep the reliability and stability, and also um, the support some error corrections or the detect mechanisms. But the connection list protocol, also in connection oriented protocol, we can say that the stateful connections. Why? Because yeah, they count the sequence number, right? They know the relations between the segment. They can reassemble the segment based on the sequence number. That means they have the information to reassemble the segments. So, they are stateful. They remember the order of the segment. So we call that the stateful, right? However, like the connectionless protocol, one of the mainstream is major protocol is a UDP. Have you ever heard UDP? So this module, intercepting communication, we don't have any challenges related to the UDP. But the UDP is very popular, um, like the video streaming protocol, the Netflix, or even sometimes YouTube or the Prime videos. They use the UDP instead of TCP. Why? Because the UDP they don't need any connection setup procedure. They just send the data to the destinations. Why? The speed is priority in the UDP. So there's no formal connection setup required and the packet sent individually without maintaining connection state. So they don't need uh, any state information. Why? Because uh, just they think the speed is very important because this service is very delay sensitive service. So we don't need to retransmit or we don't need to detect errors. Just send again and again with high speed. So that is the purpose of this protocol. We call that connection least protocol. Connection least protocol. So the UDP, User Datagram Protocol, that's a major protocol. So let's keep this the differences between two terms and protocols TCP and UDP. So there's another term virtual circuit in the TCP. What is a circuit? In yeah, virtual circuit. As I mentioned, the TCP make feel us we are connected logically, right? So the virtual circuit it means indicate the virtual the logical connections. So yeah, this is the what I explained. A server listening to specific port and receive a connection request. It it's like the procedure we call right, like when we put the number first, right, and hang on, uh, and the signal the receiver receive, and we can start talking like that. There is some call setup procedure, right? So that's why the TCP called it a virtual circuit. So the the primary the procedure is the setup, the three-way handshake. So here, as I mentioned, the number sequence number of client plus one as acknowledged number in the, the server side or receiver side. Okay, so the client send with ACK flag bits with the sequence number plus one and acknowledge number plus one. So there is the three-way handshake procedure. And second phase is the data exchange phase. So after setup, we talk. Yeah.
Professor, to go back to the previous slide, we're talking about the sequence numbers plus one. Can't an attacker set the unflagged and set the sequence number to be SC plus one and act like the client
Mhm.
for an attack
Mhm.
if it's always plus one?
In the setup, yeah, procedure. Yeah.
Like, won't this be a security vulnerability if the client knows? Like, if always there will be plus one.
Yes, there is a known vulnerability in the TCP protocols. Yeah. So yeah, that is the in the early stage of this protocol. Yeah, that's a well-known the vulnerability like predicting the sequence number of the segment. So that's very easy
Yeah.
to monitor the traffic. We can predict the segment, the sequence number or the acknowledge number. So in the real world nowadays, every packet encapsulated with TLS or secret SSL. So that is not any more issues. So we cannot see those the information anymore. So so we are in the class, so academia. We need to understand the principles of how it works, right? So we know that. So that's a good question. So the predicting the sequence number, that the typical issues in the vulnerability research. Good. Yes. Okay, data exchanges, and the last phase is a shutdown. Okay, what is shutdown? Yeah. Um, okay, data in the data exchanges, uh, it's like already I covered the slides. So they have to add this payload size to the sequence number. Okay, okay. So the sequence number is correct. Uh, that means the data transmitted successfully. So that's a way to guarantee the reliability. Okay, let's see the shutdown procedure. First, client send the packet, the send segment, the ACK and fin. Yes, finish set to one, and then server send the ACK uh, byte, ACK flag. Third one, another ACK and fin flags with the story byte added to the sequence number. Okay. Then lastly, we get the response from the client. Okay, let's finish. Finish. Okay. With the acknowledge flags. So the TCP connections has three phases. The first one setup and data exchange. Lastly, the shutdown or the terminations. And as we see, so you have to take care the sequence number and acknowledge number if you like to make these packet segments manually. And our challenge is number level 11. Yeah, they recast this one, but they suggest provide the specific port number 31337 in the level 11. Okay. Mm, okay, let's see level. Go to manual level 9. Yeah, it requires to manually send internet portal packet. So I already showed this in these examples. Send IP. Oh, there's no IP, but I can send. I can see the ARP. Okay. Actually, there is no sample code for IP packet. Anyway, you can make this like slash edit payload, edit the payload IP right, in this way. Okay. And what is the IP? Right. Yes. So you don't need to specify everything. Um, P IP show source address and destination address and flags. Okay. Yeah. That I think that's all for need. That's all needed to solve these challenges. Challenge nine, right? Yes. And challenge 10, the manually send transmission, the TCP packet, right? Actually, TCP segment that is more suitable terms. TCP segment. So how can we do that? Uh, TCP ping TP, maybe yeah. This sample code has the TCP segment and IP packet and Ethernet frame. Okay, and it has also the payload. So in the white shark, we checked the payload successfully, right? So this is the samples how to make the sync packet. Okay, sync packet assembled, right? And egg response, and then it check the response and the type of response. If it satisfied, it send this egg packet, right? So this is kinds of yeah TCP. This is the same way handshake. If you receive after send, right? What is the first send? Um, sync packet, right? Here is a functions SR1 functions. Oh, do you know the SR1 functions in Scapy? This is the meaning is send and receive one packet. So the first send here, sync packet send, right, to the interface, and then wait from the from the destinations. So if you got the response, you need to send this egg packet, the flags A, right? In case sync packet, the flags S, right? And here egg packet A. So maybe this is the shoot code, guide code for level 11, because level 11, let's go see. So manually perform the transmission, uh, uh, the TCP handshake, three-way handshake. So you need to send two packets. Okay. The first packet, what is this? Sync. Sorry. Let's say the segment. Sync segment first, right? So that's the easy way. Easy. How about the second packet? That's acknowledge against the acknowledge from the destinations, right? But how can detect the response from destinations? So you need to resolve that part. You have to you could use SR1 function in Scapy or in Python, like some there are callback functions to wait for some events, and if the events are satisfied, the functions are learning executed like this. Uh, this two-way handshake, you have to listen from the destinations, right? Maybe that kind of sniff. So if you got the second segment from the destinations, you have to send the last packet, the egg segment, to the destinations. Okay, that's the outline for uh, level 11. So do you have any questions? In the Wireshark, okay. So I will let's just see those three-way handshake here. Okay. So this file has three-way handshake is somewhere. Let's see. Okay, here. The first sync and sync egg and egg, right? So sync number very large here, right? So in the Wireshark, there is options, analyze, um, analyze, edit, preference, okay, and protocol. See the protocol and TCP. Okay, and you can see the options. Yeah, here relative sequence number. So this is default setting to the relative sequence number. So we can see the sequence number start from 0, 1, 2, 3, right? But yeah, that's a so it changed the sequence number like this when the setup start. The sequence number 0 here, and then number increase 1 at the setup completion, right? But the actual the sequence number can be seen with that option. So edit, preference protocol, TCP, TCP. Yes, yeah, the relative sequence number. So this number, see, Yeah, the initial sequence number assigned based on this standard, the RFC 793. Actually, the Unix they use this mechanism. The increment increase the number every 4 microseconds. Okay. That's the standard, and the BSD Unix system increase the number every 64K uh, half second. No, yeah, that's a 8 microsecond increment by 64K each time a connection is established. Okay, so any questions? Yeah.
Can you quickly go through what art means? I'm not really sure I understand that.
The discussion number,
Sorry.
the where,
I'm not sure I understand what art is. Yeah.
AL, ALP, source code, the sample code, you mean?
Like, I don't get why we use ARP.
Okay,
What's the point of
okay, okay. Let's see. So why we use the ALP address? Um, okay, what is good? Okay, I will number 6. ALP is a layer 2 address, right? ALP. ALP is a address resolution protocol. That is not that is not the address like a MAC address. I mean, ALP convert the MAC address to IP address and IP address to MAC address. That's RALP, reverse ALP. So there's a two types, protocol ALP and ALP. RALP. Why use that? Here, to see. Let's see the ALP table. So there is one IP and IP tables, right? So this is the IP and this is the MAC address. So we call this the ALP cache table. Okay, so ALP keep the mapping table between IP and MAC address. So in the subnet network, subnet. So I highly emphasized what's the meaning of the subnet. Like in this lecture section A, B, C, let's call that. So when I go to these sections, I like to talk with you. So do I need to ping the other sections? No, only I can talk with you directly, right? In the case, we can use ALP. In the case, we can use the MAC address, not IP address. If I have a case to talk with the guy in the section A, in these sections, because there's another network, right? So I have to go out of the this subnetwork. So if you like to talk someone uh, beyond your subnetwork, you have to use IP address. In the case, those guy, I don't know the ARP of the guy in the section A, but also he and guy they don't know my MAC address, right? But in the subnetwork, if you like to exchange the data in the subnetwork, you should use the MAC address, right? So the purpose of the ARP, that's like the converting between the IP and MAC address. Okay, so if you that's the there is some functions like NAT, network address translations in firewall, that translate a private address to public address or public address to the private address. Like that in the network, some gateway or some uh, the gateway, like only we have two gateway, right? So when we go out uh, beyond the gateway should control the address to map to deliver the data to the right person or right host, like that. That's the mechanism how if I use the IP address in the subnetwork, so IP packet uh, has overhead 20 byte normally 20 byte, right? So let's say 20 byte. Sometimes that is not trivial, but when you send the huge data, the 20 byte gonna be uncontrollable overhead. So that's the reason why we use the MAC address, the small frames instead of IP packet, right? IP packet should have IP header, but in the Ethernet frame, we don't need IP frame, IP header. So that's more efficient in the subnetwork communications. And if we subnetwork should if subnetwork communicate with another subnetwork, they have to use the ARP protocol. Okay, so yeah, like this. Usually, the system keep the mapping tables, uh, the MAC address and IP address, or like here, so it has the all informations to communicate with the gateway. What's the gateway, and then the some net mask. So based on these informations, the network uh, perform network as managed efficiently. Make sense? Any questions? Okay, that's great questions, and have a great spring break. And let's see after break. You have a good one. Bye.